So in this video, we're going to get an introduction to statistics, along with some terminology that we're going to see throughout the term. So if we're going to learn statistics, probably the first thing we need to do is define statistics. So it's the science of collecting, organizing, summarizing, and drawing conclusions from data. It's all coming from data, and then we're analyzing it. So we're going to see each of these pieces come up in our course. In fact, this first piece of the science of collecting, we're going to be talking about that this week when we're looking at sampling and different ways that we can sample data to collect that information. Organizing the data could be based on characteristics, numerical values, or things like that, which we'll talk about this week as well. Then summarizing the data, there's going to be a lot of different ways we can do this. We can do this with graphs. We can do this looking at specific values, which will be called statistics as well. So summarizing is where we get into something called descriptive statistics, which we'll talk about down below as well. But it could come through with graphs or some sort of analysis. And then once we can see those values, then we can draw conclusions, which is the idea of what does the data tell us. And a part of this could be talking about statistical significance, like how significant is this data? Is it telling us something very strong? Is our data actually kind of weak? That kind of analysis will come up closer to the end of the term, where we talk about confidence intervals and hypothesis tests. So we're doing all of these different things, and it's tying to data. So what could data look like? So it's any collection of numbers, characters, which could be described as words, images, or any other items that provide information. So let's say we were collecting data on weather. So numerical data, if it was presented in numbers, then maybe they're collecting the temperature outside. For example, it's 40 degrees Fahrenheit. So that would lead to numerical data. This idea of collecting words or characters or images, that's called categorical data. So it's fitting these different categories. So if we were collecting information on weather, then maybe that would look like a picture of a sun. It could be an image of sunshine or a cloud. Oops, drawing infinity there, a cloud, there we go. So some sort of image portraying weather. It could also just be words, so like sunny, cloudy, things like that. We could collect those words, and that would be categorical data. So the idea being that all of these portray weather in some form. It's just we can choose which way we're collecting that data. So now what we could think about is, where is the data coming from? So where does the data come from? And we're really going to focus on two places: population versus sample. Knowing which place the data is coming from, comparing these two, it tells us so much about the strength of our data. So if it's coming from population data, that means that we have collected all of the data. Whatever we're interested in finding, we got all of it, and now we're analyzing it. Sample data is just a portion of this population. It's a smaller grouping. And with that, it can represent the overall population, but it could have some error to it. So let's talk about the idea of sample versus population in this little example here. So we're going to draw a picture representing the concepts of sample and population, and we're going to show an example for if we were collecting the average height of an SPSCC student. So the idea being, population is big. It is everything. So what I'm going to do is draw a big box here. And that big box is going to be the population. And for this case, where we're interested in the average height of SPSCC students, that means that our population would be all SPSCC students. So this is where we get information from absolutely everyone. So in terms of what we would do with this population data, the idea is that we collect the heights of all SPSCC students, and then we take the average. If it's a sample, so where I have this big box representing population, the sample is just a smaller portion of this box. I'm going to draw this little circle within the box. And the key being that it is inside the box, because this is part of the population. We wouldn't want to grab anyone from outside of this population. And this would be our sample. And the idea being that this would just be some SPSCC students. It would be up to the researcher to decide how many people. This would be their sample size. So let's say I decided to collect 30 students. Let's say we collect the heights of 30 SPSCC students. That would be the idea of a sample. So where we're interested in the average height of SPSCC students, if we only talk to 30, then that's just a sample. Now let's talk about values that come from these different spots. So let's go back to that population data. If I collected the heights of all SPSCC students, and let's say I took the average and I found the average height is 5 foot 8 inches. That exactly answers the question that I was looking for. If I'm looking for the average height of an SPSCC student, if I had population data and calculated that average, 5 foot 8 is it. That's the answer. But now if you think about collecting that data, just imagine for a moment I said, okay, your project this term, go out there and interview every single SPSCC student and get me your report in 3 months. It's possible, but there are a lot of students, and this would be very difficult to obtain. And this is going to be kind of the theme we see with population, that if we have population data, our values are exact. There's no error with them, but very difficult to obtain. Maybe sometimes even impossible to obtain. So I'm going to go back up here for a moment where we talked about how population data is all of the data. And let's just make a note that this is difficult to obtain, even sometimes impossible, but accurate. It is exactly accurate. It is exactly what we would be interested in finding. Now, sample data. Let's say I took this sample of 30 students and I calculated their average, and let's say we got 5 foot 8 inches as an average from that group. What we could do, and this is part of our course that we're going to do later in the term, is we got this information from a sample. What we could do is think about, what does that sample tell us about the population? Because what should happen is the values should be fairly close together. They're rarely exactly the same, but they should be very close. And what we can do is take steps to make the sample even better. Like if I switch this from 30 students to, let's say, 100 students, and something that could make it even better is the word random, making it 100 random SPSCC students, that all strengthens the sample so much, to the point that we get out this value that should be very close to the population value. And we'll talk a lot more about the steps we need to take to strengthen our samples. But the idea is, if I go up above to where we talked about sample data being a portion of the population data, this is easier to obtain. Interviewing 30 or 100 SPSCC students, we could do that. So it's easier to obtain, but the trade-off is that there's going to be some error involved. But we can take steps to limit that error, and then we're even going to use statistics to kind of analyze that error. How much error can we expect? What can we do to reduce that error? And things like that. So that's really the idea between population and sample. Population is all of this data that we're interested in. Very hard to get, but incredibly accurate. But what we do in statistics is we focus more on this collection of sample data. So we take it from the population, we take this smaller sample that's easier to obtain, but we just keep in mind that there is error involved. Last piece we're going to talk about here, which I mentioned this term descriptive statistics up above, and then this idea of working with samples and population is the idea of inferential statistics. These are the two types of statistics we're going to focus on in our course. So descriptive statistics, this is where we're describing data and we're analyzing specific numerical values. So we might look at mean and median and something called standard deviation. All of these we're going to analyze from numerical data and evaluate these numbers coming through, and that's going to be descriptive statistics. Inferential statistics is where we're going to generalize from samples to populations. So we do this with confidence intervals. We also do this with hypothesis tests. And it's this idea, like we were talking about up above, where if I take these 100 random SPSCC students and I see this average height, what does that tell me about the population? What assumptions can I make about the population? And what, if any, are the errors coming through with my data? All right, so there's a little introduction to our first terms of the class. What we're going to do this week is get more into data collection, so how we collect data, how we can strengthen these samples, typically with randomness and larger sample sizes, and as well as developing experiments and what creates a really strong experiment to make really strong data.